All right, thank you. It is my pleasure to be the moderator for this fine set of panelists. I'm going to maybe just ask a couple of questions to get us started, and then I'll certainly be looking to questions from our audience as well. But since we haven't heard from Christy and Rick yet, formally I should say, would you guys mind just introducing yourselves for folks?
Hi, everyone. I'm Christy Pullen-Fedenik, and I am a scientist at the Natural Resources Defense Council, where I focus largely on the use of emerging techniques and tools, so not only in chemical evaluation, but also in geospatial techniques, to understand and educate the public on the chemicals that they can encounter in their environment and how it is that those chemicals can impact their health.
Hi, everybody. Rick Becker. I'm with the American Chemistry Council. I run our long-range research initiative, which is a research program aimed at developing new and improved methods for toxicity testing, exposure science, and risk evaluation. I've worked for a number of years on emerging risk issues, including endocrine, alternative methods to toxicity testing, those kinds of things. Thank you.
Great, thanks. So maybe just to get us started, each of you represent a different type of stakeholder or interested party, and so I'm sure you guys have different perspectives in terms of what types of information or even processes you feel are valuable in terms of building confidence. And I'd be really interested in hearing your thoughts, each of you, like what is the one or two sort of types of information or processes, and I'm distinguishing those because they are different, that you think is really valuable in terms of building confidence with, let's say, the affected populations. And by all means, anybody can go.
Well, thank you for giving me the open mic. So I worked in this area thinking about alternatives for quite some time now, and thought about, going back to the tough ages of slogging through round-robin kinds of reviews for testing and validating methods, only to find, like everyone, that by the time you get around to finalizing the 7 labs or 8 labs or whatever you've done, that the technology's changed. So we live in this era where the technology is changing faster than we can keep up with. And so however we develop scientific confidence, we have to recognize that that technology moves farther ahead and faster than we've anticipated. So the ability to develop confidence means that we have to go back to kind of first principles in science and think about how we're going to do that with technologies that are proprietary, continually evolving, because we don't want to get locked into, the technologies of 2017 because we're moving ahead. The new technologies come forward more rapidly. And so as we've thought about this and worked through some of the data sets that become available, we've developed what we call kind of a generic scientific confidence framework. But it all begins with problem formulation in decision context. And so we heard a number of different, in the case examples, different problems, but did we really hear the problem formulation of what in the decision context you're trying to use that data or those methods or prediction models for? So it's very important to be very specific and explicit in the problem formulation, and then that can help guide you when you're trying to decide, do I have enough confidence in these models, methods, data, information to support the decision that I need, right, or that I need to make. So problem formulation is first and foremost very important in this area. The decision context needs to be explicitly stated in problem formulation. And then we have the challenge we've always had with new methodologies in science is understanding how they perform analytically. And that's nothing new. Even if they're proprietary, there has to be an attempt to show that you can get reliable data, day to day, day in and day out, the same results, plus or minus, whatever your acceptability criteria are. And then you also have to know, have a set of positives and negatives. We call it sensitivity and specificity. Somehow you have to ground truth that to something typically low throughput, if you're talking about testing. And then you need to know what domain of applicability works. Does it work for this set of chemicals and not that set? So sometimes when we've tried to do this validation, we've really overreached. And when we overreach and say, and try to imply that it works for everything, then, and it's typically pretty easy to show sometimes that a method doesn't work for everything, then the utility of that method gets, I don't want to call it smeared as not valuable. But if you would define it for a particular use in a particular domain of applicability, domain of category or classification of class of chemicals, maybe that's a really good method for that. So it gets to the tiered approach, but being very explicit in that so you have to have analytical confidence. Then, like so much we're doing today is prediction modeling. We want to be able to extend not just our observations to, what we can actually measure, but then also how can we predict? So the good example is the case example about the eutotrophic assay. Using the data that's available, one can actually predict results of the eutotrophic assay, so you don't need to use that. But what gives you confidence in that? Well, it's that data set that was developed, and then the prediction model that was developed based upon those data sets. So you need to have some kind of prediction model, whether it's explicit or it should be explicit, whether it's quantitative or qualitative. And then one needs to discuss why the training set and the test set performs well enough to be used for that decision context. And that's essentially what's been done with some of these prediction models. Again, it's for the decision context that you want. You want to, for the eutotrophic, replace the eutotrophic assay with the prediction model, if you would, based upon ToxCast Tox 21. Then the third component of that, and this is not rocket science, of course, it's just good science, is you have to be transparent in everything. Share the data, share the models and methods, let other people play around with the numbers, build confidence that the method model works, and then provide the justification. Write it out, be clear, be transparent, why one thinks that the data, the model, the methods, prediction model will work for the intended purpose, for the decision context. And then that allows to have that debate, that discussion, the peer review or peer consultation. Are the data sufficient to support that use? Why do you have confidence in using it for screening versus, say, definitive testing? And so those kind of components really allow you to take these methodologies and move them forward for intended uses, specific uses, and not necessarily for everything all at once, but use them in a way that makes sense to support the decision context. So thanks for your patience and letting me get up on the soapbox and have that say. Thank you.
Thanks, Rick. Do any of the other panelists want to comment either on the question or, okay, Christy?
So, yeah, I would say that, so I'm a new mom, so many of you guys probably don't know that. And so I can wear my scientist hat or I could wear my new mom hat. And so right now I'll wear my new mom hat. I think that from a public perspective, I think building confidence is more than just confidence in the tool itself. It's also in the user. So if you give a hammer to a carpenter, they can build you a beautiful gazebo. You give a hammer to a window washer, then that could be really disastrous. And so, in a sense, you do want to have a fit for purpose use. But ultimately, I think that building confidence in the use of these tools would be correctly identifying and having a regulation or a decision that allows for the removal of a harmful chemical or harmful chemical class from products that we're actually using. So demonstrating that these tools can be used in a way that's ultimately protective of the public and of public health in a timely manner. And so I think that confidence from a public perspective at least would be a little bit removed in some ways from the tool itself, but also just knowing that that tool can be used in a way that's ultimately going to benefit the masses in a way.
That's actually a perfect response for a segue into my next question, which is, it seems that one way in which we can build confidence in the application of these new methods is to demonstrate success in their application. And I'd be interested from hearing from each of you, what do you think are effective metrics of success from your individual vantages? Carl.
At some risk of referencing the past, actually Rick and I were talking after my talk that one way to do this is, not rocket science, but we have seemingly fairly reliable tests in the past that have worked. And so if we develop the new faster science, what we should probably do is use the comparison with the success that we've had in the past so that to see how well it turns out. I assume that's the way things are done, but if animal studies have been pretty good, then let's check the faster various kinds of studies we might do to see how well they match successful animal studies in the past. One step.
I would add that, success for us has a lot of different flavors. So first of all, there's the success in the market. And part of that is really, is there innovation? Are we seeing people avoid entire classes of chemicals, for instance, because we've been able to make a strong case based on the tools that are available to us? And so whether or not we're seeing that innovation in the market is one step. Christy mentioned actual regulatory decision-making, and we heard examples of timelines this morning. I often use slides that talk about the triclosan decision and the fact that the first monograph came out in 1974, and the decision was made in 2016. And I think that faster is better when we're talking about things that are known to be harmful. And so the ability for these tools to help us make decisions, I think, is definitely a measure of success.
Great. And Tara, if you want to jump in at any point, just wave. I can see you on the camera, okay? Okay. Maybe just one last question before I turn it over, which is, oh, go ahead, please, Rick.
So I think we have to be, we have to challenge ourselves to use these new technologies better than we've used the older technologies. And by that, I mean we have to challenge ourselves to harness our power of understanding of biology in making these decisions that we need to make about product safety better than we have before. When one thinks about the animal types of toxicity studies, and at some point that was the best available technology, right? And we still have a lot to learn about physiology, pharmacology, toxicology, medicine, if you would, and pathogenesis of diseases. But we now know a lot more than we ever did before. So I think we have to really challenge ourselves to say, can we develop constructs and the frameworks that allow us to better base our decisions on biology to help us make decisions about safety? And it's not about harm or not harm, if you would, because the toxicology will always tell you at some dose we can produce harm. It's a question of understanding that in the context of the biology, the doses that produce responses, and then making sure that we can use those chemicals safely for applications by limiting the exposures to the to those chemicals so we don't produce harm or don't produce excess risk or extra risk.
Okay. Christy, then Carl.
Yeah, and just to add to that, I would say that ultimately also we want to be able to use the tools that we have available to us to answer the questions that we're asking. So that doesn't necessarily mean throwing out the baby with the bathwater. So if we have a tool that's best available technology that existed or has existed for 30 years and works, then we don't necessarily have to replace that if we know that it gets us to where we want to get to in a timely way. And so how do we use a combination of tools to answer the questions that we need to answer, to make the decisions we need to make in a way that's timely and relevant and protective of the public health?
Carl?
I just want to amend what I said earlier. I was thinking in a particular context, but we may have studies that have been very useful and pretty accurate in the past. We should use those. They needn't be animal data, but it depends on the question you're asking. Okay. And we may have them. If we don't, then we'll have to think of new ways of validating them to see how accurate they can be and how quick and how accurate they are.
Okay, great. Well, so this actually is a great segue into the next question I wanted to ask. I'm going to change the one I wanted to ask to a different one, given your remarks, and it might actually bring Stan into responding to this question. But it's already been alluded to in this panel, and then it was certainly talked about in the discussions around setting up the EDSP, which is not only are the technology and the tools rapidly advancing, but so is the science itself. And one thing that we heard from Dr. Goldman is the conventional ways that the agency had approached validation posed challenges in terms of setting up that battery in a timely fashion so we could actually get to start screening potential compounds for potential endocrine activity. And so Stan, you brought up, you raised a sort of a new model or an evolved model where the idea is using sort of a performance-based approach, right, where you identify a set of reference chemicals and then use that as a way to assess a potential alternative method for a particular application. But then, there's still the reality that the science continues to evolve, and so the reference set of chemicals that we think may cover the domain of interest today might be very different, 10 years from now, when our understanding of human biology and disease etiology and pathology has evolved. So how do we sort of avoid kind of creating a different type of system that becomes stagnant, but also allows us to actually make decisions? So I'd be interested in anybody's thoughts on that.
Yeah,
Yes.
thank you, Jennifer. This sort of builds off of Rick's previous comments. I think the performance-based approach, and Maurice will probably talk about this possibly tomorrow. The performance-based approach is a new paradigm. And coming up with those criteria, those considerations are a critical leapfrog over our past very stovepiped approach. And what Rick was talking about is the frustration that we have based upon, is you're talking about a moving target. You're really trying to design the paradigm around what is the biology, what is the process, what is your purpose, and AOPs is one of the defined approaches that we are looking at in the OECD IATA integrated assessment testing approach. So that defined approach really requires careful upfront thought about the biology, pharmacology, clinical medicine, and so on that Rick spoke to. But it also, with that, can get us a lot farther and a lot faster. And some recent retrospective analysis, actually, of the EDSP program and reference lists for different assays, for the AR assay, for the transactivation assay, for the eutotrophic assay, we actually found out that all the effort that we put into generating reference lists for each individual assay, actually, if we just used one reference list we could cover all of the biological space. So again, this comes back, it's intuitive in many ways, but if you focus on the biological space, you will find exceptions. You will find exceptions. Some chemicals are going to give you surprises. You learn from that, and that's part of this process. A part of the performance-based process is you actually learn by doing your testing, and you're testing more chemicals versus the old approach was you tested 5 or 6 chemicals, and everything was based upon that chemical space. Mm-hmm. And so it's very limited, and that's why you get stuck in time, and you get a lot worse surprises. So that's some of the aspects. And I mean, we could have a whole nother discussion, workshop on performance-based approaches and the new paradigm. And I think Anna's talk will also touch on that too.
Great. Any responses from the panel? No? Oh, Rick.
So just to echo, I think what Stan said and provide a little, maybe a finer point on that a little bit, which is that as we do this, we learn more and more. So there's this lessons learned approach to performance-based validation or fit-for-purpose validation, however you want to call it, fit-for-purpose scientific confidence building. But I think we need to be if you can think about those key elements, kind of what I talked about, domain of applicability, sensitivity, specificity, what works and what doesn't work in terms of classes, then that and you share that information, right? And that allows collectively the community to build from that, build better models, pull in other classes that didn't work initially and work on those. So I think we have a new way of kind of sharing information, sharing data, sharing models that we didn't have before, right? So that can keep up with the technology. I think we have to set that our goal, keeping up with the technology.
Just to push back a little bit, Rick, and this is something that we had as a conversation in the organizing committee as well in the previous planning calls, is you have to have, and this was touched on by Brandon, you have to have a mutual sharing. And there has been resistance by many sectors to share and to actually build out aspects of those models. And they have the data, and they use it in their decision making, and they have told us that they use it, and it's proprietary, or it's part of their business model. And then others have said, well, we're willing to share. So I think I'm behind you, and I support what you're saying. I would like to see more of the private sector folks, stakeholders who have that kind of data, actually bring it.
Proprietary data is always a challenge, or proprietary methods as well. So a number of the ToxCast or Tox21 methods can be proprietary too. So we have to also, part of that workaround is figure out how you can develop confidence in proprietary methods that you may not have all the answers to in terms of what they're doing or how they're doing it. But you can see utility in perhaps using those models. So I think that gets to one of the challenges of performance-based validation, is that being able to be comprehensive in that way, but also looking at orthogonal assays that can be run probably at low throughput or in some other comparison, maybe some other high throughput methods that you can have a comparison that allows you to develop some confidence in those other methods.
Yep. And there's also some interesting provisions under the new TSCA that deal with proprietary information and CBI that might change the conversation a little bit from the conversation that had been happening. So I have many more questions, but I realize it would be very selfish of me not to open it up to the rest of you all. So does anybody have any questions from the room or online? Maricel?
Thank you, Jennifer. Thank you all. This has been great so far.
Oh, sorry. Could you give your name?
Maricel Maffini. I'm an independent consultant. It has been said that science and knowledge, science is a target, it's a moving target, and we are gathering knowledge with time. And something was said just a few minutes ago about trying to keep up with the technology. I was wondering, what is your idea of, with the new technologies and the new knowledge that then is going to be put into work with new technologies, how is it going to be used to protect public health? Because it's going to be just for brand new chemicals? Is it going to be used to revisit the safety of chemicals that are already in the marketplace? Because if we are constantly changing technologies and acquiring more knowledge, but we don't look back to the safety of the chemicals that are in use, I have a hard time figuring out what is the success behind this.
I'll take a crack at that too, because I think that the regulatory structures evolve as the knowledge evolves too. They typically don't evolve. They're typically step functions, right? They're constant for a while, and then they evolve. So I think the good model for this I will point to is something that's done in EPA's Office of Pesticide Programs, where they make a very good use of kind of standard approaches, problem formulation and standard approaches, but then there's also this opportunity to come and work with the agency and then work within their science community. I don't know if they call it communities of practice or dialogue committees or something, to bring new science forward for tackling some of the existing chemical problems and new chemical problems. So I think part of the solution has to be develop the infrastructure that allows the science to come forward and then be shared in a way that there's better connections with the decision-making process. And we heard a little bit about that in some of the earlier publications about some of the processes lagging behind some of the development of science. So we need to bring those communities better together a bit more. And I think that under the new TSCA, which calls for tiered evaluation, a reset of the inventory, and then tiered evaluations of chemicals, there's this opportunity to bring some of this new science forward and have it applied in a way that helps with either priority setting or screening earlier on, or rather than kind of waiting until you get the big, thick, comprehensive risk assessments in order to apply this knowledge.
Christy.
Yeah, and I think, going back to, kind of a fit for purpose discussion, if we go back to the examples we heard earlier today that said we've had 30 plus years of information on formaldehyde, you don't necessarily need a new tool to determine whether or not that chemical is carcinogenic or not. And so at some point, allowing us to make decisions with the information we have rather than completely resetting everything and requiring new information in order to move forward on a decision. And so I think ultimately, if we think about fit for purpose, for data-rich chemicals in which we have a lot of confidence in the data that we have available to us, making decisions based upon those. I think if we're looking for chemicals that are new and they have less information available to them, then using those data in a way that could be protective, again, ultimately of public health, so ensuring that we have, decreased numbers of false negatives. So maybe it's also thinking about and rethinking about the way that we think about toxicology and the use of toxicological methods to evaluate chemicals, but ultimately just identifying places where we can fill gaps with these new tools and helping us to inform decisions. And I think that happens in a number of contexts, not necessarily even having to rely on these tools if we already have a completely rich data set and can make public health protecting decisions. And then using these tools to really try to identify chemicals that could present a harm to the public, particularly if it's a new chemical, then having a threshold that then allows for additional information to say that that chemical is not harmful. So you can shift, again, the paradigm in a way that I think would be ultimately beneficial to the public, but just ensuring that we're using these tools ultimately to uphold the mandate of, say, agencies like EPA that are there to protect the public health.
If I may just throw one more sentence, shouldn't a systematic review system be an answer to review the safety of chemicals, where every 15 years or whatever time frame is, depending on the data that is available for chemicals, there should be a prioritization process and the safety of the chemicals reviewed. And it will be reviewed at a time where, whenever it happens, with the information, the knowledge, and the tools that are available at that time.
If I would only add that there's the possibility of using some of these informatics tools to help with the prioritization of what we go back and look at. If we're starting to see problems with a particular structural element, or if we're starting to see problems based on a new chemical, or new chemicals or new analyses, that could very easily trigger what we go back and look at and prioritize for revisiting.
Stan, I think, oh, sorry, go ahead, Carl.
I wanted to comment on the structure of the discussion here. I think staying abreast of the science is an important thing. I think that companies that develop new science that they find helpful provides them with lots of incentives to go talk to the agencies. I don't know that there are the same incentives for independent scientists at universities and other places like that to come talk to the agency about their new tools. That may be, but I know in other contexts where there's a natural incentive for one side to, or one group of people to have reasons to present to an agency. You don't want the agency listening only to that. You want a broader scope for what the science is, and you may want to have I don't know, Science Day or Science 2 days or whatever in a certain area. On the other hand, the EPA, for one, and probably the other agencies, are starved for funds and they're starved for time. So how you do all of these things, I think, is a problem. And staying up in a balanced manner with the science that may be developing may take some thought.
So Stan, I think, is going to respond to this conversation, then move to Kim. Okay.
Yeah, I wanted to respond to the systematic review question because I thought that was a really good, insightful one. One of the things that we're exploring in the area of systematic review, whether it's endpoint disease or chemical-related systematic reviews, is basically a repository or registry of protocols, systematic review protocols, so that someone else can go back and recapitulate that systematic review or use the same criteria and extend or build upon that criteria for a future systematic review. In addition, again, in collaboration with NIH, NLM, and NIST, we're looking at automation and using artificial intelligence and machine learning to actually automate some of these processes in the systematic review process. As I said earlier, it is costly to have experts sit down and do the searching, abstract text mining. You actually are talking about a fairly complicated process, and to use machine learning to do some of those steps, to at least some of those early screening steps, is a very important cost-saving measure and something that we're investing as a multi-agency effort. So I just wanted to bring that to you all's attention. And it does involve the research community, a different research community than the toxicological area. So bringing different communities together has been a key aspect to that effort.
To add a note here, and we've talked about lots of new methodologies, I think, but there tend to be a focus on those methodologies that are providing us information on biological activity. But we also have, and Meredith mentioned this, tremendous efforts underway to do a better job of assessing exposures, predicting exposures. And that includes exposures at the kind of the intake or contact level with the receptors, with humans or environmental receptors, but also biologically based dose-response modeling as well, where we take better understanding of the physiology, understanding how the chemical moves through the system, whether that's an ecosystem or the human systems itself, and not lose track of that we also have the challenge and the opportunity to bring that information together as we go forward in these new technologies.
Great. Kim?
Yeah, I'd sort of like to go back to a high-level question, which is around the topic of decision-making under shifting paradigms. So we have a previous paradigm that was based on animal studies, a new paradigm that is largely human cells in vitro as the source of information. And so the question is, what do we do about conflicts between those two sources of information when we don't know what the origin of the conflict is? We've also heard from Carl about the utility of defaults. So it's actually useful to use that very large database that we have of animal studies. We've heard about ground truthing and using reference compounds based on the previous paradigm. But I guess the question I'm trying to think through is, what do we do with the inevitable conflicts between the old data, which is the gold standard data, and the new data, which we anticipate being more relevant and informative about the human problem? How do we resolve that need for something to refer to in the context of doing better science?
Anybody want to take that? And I might add like another spin, a little bit of a spin to that, which is there's also the issue of there's contention as to whether or not some of the existing quote unquote gold standard data actually is. And so that debate continues. Yeah, without even bringing in the new methods. So it's a lot to grapple with. I like that question. Carl.
Well, one answer is to do the appropriate experiment, right? And I don't know, there may be no non-question begging way to do that experiment. But I do know, for example, just think of a historical example. Let's see, EPA conducted some experiments for identifying carcinogens quicker with animal data, the gold standard, I think, and then they looked at a variety of other things to see how close they were. At least one account I heard was, actually I had to talk to a certain woman. She was really good at identifying carcinogens from chemical structure and so forth. But you could do, you'd have to think hard about it, I think, but a kind of blind experiment on each side to see what you can come up with. There's probably a way to settle it. I'm not articulating it probably very well, but you go with what you know, and then if you think you're at a cusp for moving on, then you try to do the right validity experiment to see which you use, I suppose, would be my thought.
I think Anna wanted to add.
Yeah, so for those
I'm also doing a terrible job as moderator, reminding people to announce themselves. I let Kim get away with it. I'm not going to let you get away with it, though.
Thank you. So for those of you who don't know me, my name is Anna Lowett. I'm going to speak tomorrow. I am currently one of the co-chairs of ICVAM, which is the Interagency Coordinating Committee for the Validation of Alternative Methods. Say that fast 3 times. I also am a Senior Science Advisor for the Office of Pesticide Programs, and both Rick and Stan keep adding to my presentation, which I was already struggling to fit in 15 minutes. But so the question that was brought up a few minutes ago about using the animal as the gold standard was one I was hope would actually come up, because it is one of the big challenges that we face. For those of you who don't know, my office, so in the pesticide arena, more animals are used in pesticide testing than any other sector, including pharmaceuticals, because in the pesticide arena, you can't go to humans. So everything is done in animals. And my office has been strongly committed to reducing our animal footprint for the last few years. And in fact, we waived nearly hundreds, if not thousands of studies at this point, saving tens of thousands, if not 100,000 animals by now. But our commitment is not only just about reducing our animal space, but about doing better science and making better public health decisions. And one of the things that's, this issue is an important one to us. And one of the things that we're finding is that we're having the most success in areas where either human data exists, that you can make those comparisons. So for example, there's quite a bit of work being done under collaboration with Nicole Kleinstrewer at NICEDM with Cosmetics Europe, and they have a couple of publications that will be coming out in the next 2 or 3 months looking at comparison of sensitization data in animals and humans with largely the 3 guideline studies that are approved for OECD for skin sensitization. And it's actually really encouraging that the 3 in vitro studies in different ways and forms actually predict the human data better than does the mouse LLNA study, which is really exciting. So we can move away eventually move away from the mouse LLNA study and make better public health decisions with 1 in vitro study and some predictions out of the OECD toolbox. That's really cool. So we're getting there. I think another area where we're going to start to have a lot of success is areas where we know the rodent is actually not a very good model. So I think there's a lot of progress going on in the area of skin irritants and effects in the nasal cavity and through the lung tissue. Quite a few industry partners are working towards actually eliminating the 28-day in the rat, the 28-day and the 90-day rat inhalation study, just because it's not really relevant to humans. And we can do better with animal 3-dimensional tissues combined with sophisticated pharmacokinetic modeling and just avoid the animal completely. So I think as we start to build some of these experiences with respect to moving towards the new approaches, and particularly coupling in vitro with predictive modeling, that we will actually just incrementally, one by one, build our confidence, so that when we start to tackle them really complicated things like cancer and developmental repro, that we'll have enough experience under our belt to tackle them, in a way that we don't have to hold the rat and the mouse to the gold standard, that we're thinking about human relevance and we're confident in using adverse outcome pathways and linking key events to apical outcomes. So we're going to get there. It's just going to take some time.
Did you want to? Okay, go ahead, Christy.
Yeah, I also think, so the NAS Toxicity Testing in the 21st Century, the 2007 study that looked at really outlining how we would, or we could use these tools to really shift the paradigm in toxicity testing. One of the first steps or key recommendations from that report was to have a knowledge generation step in which we started to really try to understand the biological pathways at play in various disease processes. And in some ways, we've made some progress with the AOP and the AOP wikis and, really crowdsourcing a lot of the creation of this type of knowledge, but we still have a ways to go. And so I think that the skin sensitization example is a good one, where we have a pretty well formulated and pretty well identified AOP and understanding of mechanisms, so we can use in vitro data sets and modeling to predict some of these outcomes. We're not that in that same place for other areas yet. And so in some ways we want to be able to ensure that even though these conflicts are certainly going to occur, that we go through the processes we need to in order to ensure that the tools and methods are being used to answer the questions that it is that we are trying to answer. And so I think that when, if we have, again, a data-rich chemical and we can use information that's available to us, even if it's conflicting to, say, upgrade the designation of a particular chemical, then that could be useful. I think if it's a relatively new area of science or a new chemical, then being able to, again, still rely upon our gold standard or even expanding our gold standard in a way, so looking at non-guideline studies. And so the EDSP, for example, for their ER model, looked at guideline studies as well as those that weren't performed under the guideline principles and found differences in the accuracy associated with that model. So maybe some of it is also utilizing the animals that we're using in a way that's outside of that which has been absolutely validated to really try to understand the universe of biological functioning. So I think that having a process that allows us to generate information, that allows us to use the tools that we have existing in a way that's potentially even will open up other biological pathways to us, and then exploring the ways in which we can shift over time to be able to get at those types of conflicts would be useful.
Great. Kevin?
So it strikes me that one of the challenges in building confidence in new methods is that we're going to have different stakeholder groups with different standards of proof, as we heard this morning, and different tolerances for false positives and false negatives, as we've kept hearing about. And so I was just curious to hear people's thoughts on how, as we sort of start using these new methods, we can bring stakeholders together in productive ways to work through some of those differences in standards of proof. And I don't want to put you on the spot, Brandon, but if you wanted, you mentioned analytic deliberative processes this morning in your talk. I don't know if there are some promising avenues along those lines to have that kind of deliberation among stakeholders about these standards of proof, or if others have good examples or experiences along those lines. But I'd just be curious to hear more about that.
Well, there are opportunities to build not complete consensus, but consensus, as I said earlier, that's segmented, that focuses on particular areas. So if people have different thresholds for false positives and false negatives, there's at least the possibility of saying, well, in this segment of the line of differential outcomes of your tests and experiments, that we agree that this is unacceptable, that this is toxicity, for example, that's too high, or a false negative rate that's too high, and we agree that we want to work to get that down. We may still disagree on certain criteria and fight that battle out in various ways that might well not involve consensus, but at least we can agree on these particular areas. One method that I did not get into in any detail, but which has proven fairly successful in the environmental and natural resource conflicts that has been applied to, is structured decision-making, which excuse me, Robin Gregory and his colleagues have developed, and I put that fairly short book describing how it's done in my bibliography. What they're usually dealing with is not very large inclusive processes, but more small end stakeholder groups. For example, somebody representing environmentalists, somebody representing industry, somebody representing government, and maybe First Nations or Native Americans and so forth. And they tend to have the same kinds of conflicts we'll be talking about, is that the technical data are uncertain, the values are diverse, there hasn't been resolution in other forums, and so what you are doing here is bringing these people together And you're getting them to start with to focus on the values that they feel are important to this decision. And they don't all have to agree on what the important values are, but they have to be willing to agree that those are values that they're willing to have discussed and analyzed in the context of that decision. And then work on finding indicators of how well those values are addressed by the various decision options they have. So it's really a decision-focused approach. It's not aiming at creating trust, although that may happen. It's aimed at saying, we want to get convergence here on at least a small number of decision options that everybody agrees are in the realm of possibility, and then work through those remaining trade-offs between these different values and technical data. I don't know that it's ever been applied in the area of environmental health specifically, although environmental health has sometimes been one of the issues in these processes. But that's one example of how you might be able to get, again, partial convergence on some of these issues.
Are you responding to this? Okay, go ahead.
Hey, thank you, Meredith. First off, I just wanted to give a comment. Thank you for really thinking about chemical life cycle. I feel like there's not enough of that forward thinking, and I just really appreciate that type of thinking. And in that vein, I forgot to introduce myself to speaking to your point.
Yeah, let Kevin get
RPO,
a word in.
Defense Threat Reduction Agency. I really think a lot about, so there's 80,000 chemicals that may be introduced into the environment. There's a lot of talk today about parent compounds, but less so about metabolites, right? So we have 80,000 parent compounds, maybe 3 metabolites apiece that may be more toxic or more persistent than their parents. So it's more like 1/4 to 500,000 compounds. How do we begin to address this problem in regulatory space?
I'll say that as we look at the perfluorinated chemicals, for instance, that's a case where so many of them degrade to the same metabolite, and that's where the problem is, right? And so looking for those paths is particularly important to us. And I'm sorry. But the other challenge for us in California is that we have to name the chemical in the product. Right. And so there are compounds that get used in the manufacturing process that we're concerned about, but maybe they don't end up except as residuals in the product, and how do you attack that? So I'm really not offering any solutions other than to say it's a concern for us too.
Great. I'm going to get to you just after I get to this question online. So we have a question from Rory Connolly online, which is, how are confidence and trust effectively communicated to non-technical stakeholders, given that there are issues with scientific and technical issues in vitro methods to identify toxic hazards and dose response?
Well, again, I think what you need to consider is, what is the context here? Are you trying to do a population-wide communication/education type effort, or are you doing something much more specific, like getting information to the California consumers who are shopping for products that might have issues, or the people in South Carolina who are finding out that they are basically way stations for the creation of potentially bioactive chemicals. In general, when you're talking about locality or audience-specific questions that arise in the general public, it has to do with things like, am I at risk? Who's at fault? And what's going to be done about it, either by me or somebody else? So when you're talking about toxicity testing, you're talking something that is in general far upstream from this. you don't even, you can't even see the answers from where you are right now, much less formulate them. So some of the information that we've already observed that people are coming up with, whether it's you're doing proactive work on identifying potentially bioactive chemicals, or you're looking at the wide range of endpoints that in California you're looking at, those to some extent can be reassuring to people. They may not need to know all the details, but getting the sense that somebody is on watch and looking out for these possibilities can be reassuring. On the other hand, the notion that the environment is full of these potentially dangerous, but perhaps not things, can be fear-arousing. The people in South Carolina, for example, here they are taking pharmaceuticals for personal benefit, and now you're telling them, well, and there may be some downsides to this, if not to you, to the local environment, maybe to their visiting grandchildren. There are lots of potential opportunities for people to be aversive and deny the risk, and actually, instead of being the usual assumption of risk professionals that the public is overly scared, you may have a different problem, that they're not sufficiently scared, motivated to find out what's going on here and to possibly take some protective actions themselves. So I think it's a complex topic because we've heard a lot about transparency here today, but the problem is there's a difference between sort of fishbowl transparency, where you do a data dump and you put all this stuff out there, and you don't provide people with either the tools or the context for understanding what the data mean. Now, the professionals can work their way through it, and again, for this field, the professionals may be your primary constituencies, at least for the next several years, but it makes it hard for the organizations and the individuals who are less professionally qualified to figure out what this means, not just in terms of the intentions of the people providing the information, but the questions that perhaps the professionals themselves have not asked, but that larger population can bring to the discussion. So I don't have a great solution here, but there are a lot of things that need to be taken into account.
Is this a new question or a response to what was just said? Oh, well, okay. Is it new or a response? Yeah. Okay, so I'll have Carl respond, because I think you were trying to jump in, and then I'll go to you and then to you. Is that okay? And then time check with my NI. So we have 11 minutes on the clock, but I know that the agenda says, 20 till. Which should I be following? Okay, all right. So I think there should be plenty of time for all of that. Good.
Okay, quick, in a way, this is an amendment to how you, well, addressing one of the questions earlier, but it may fall in Brandon's camp. One of the things you want to do when you have technical discussions, I think, is make sure you've got appropriate representation by the different sides to the debate that are involved, and not have it one-sided. So that's point one, just make sure that it's appropriately open. I have talked to people at EPA, and I said, do you see people come lobbying you? And he said, yes, every week. And I suspect those are not the health people or the environmental people, but rather the companies that are, so you don't want that. The second thing is, there's a technique, and Brandon can maybe talk about this. I'm aware of some people that have worked in, I think this is probably the wrong term, but mediation, where you get people in a room and you cut off communication with the outside world so that they can be candid with one another, they can talk the issues through, and so forth. And that's a much different circumstance than, the meeting takes a little break, somebody goes out and phones the boss or the chair or the head of the department or whatever and says, what should I say? But you try to work it through in a more confidential manner to get, you can probably make more progress like that. Unfortunately, it takes more time, and I don't know what Brandon might say about that, but suggestions.
Well, just briefly, is mediation definitely has some benefits, but one of the challenges of getting people into a room and not letting them out until they agree is that, first of all, you have to consider power imbalances.
Yes.
Which include knowledge as well as various other factors. And so isolating them may not be as good for some participants as for others. Also, as along the remark I made earlier about requiring consensus, is in general, mediators are extremely interested in coming out with an agreement because that counts as success for them. Yes. So when you don't get an agreement, sometimes mediators can force one, which again tends to be biased against the weaker partners in that dialogue. And sometimes what you want is not so much total agreement as you want to know, we agreed on this and we didn't agree on this and this is why, and then let's expand that discussion to figure out if we can come up with a new set of solutions, mediated or not.
Great. Good.
Sabita Papanini, regulatory toxicologist at Dow AgroSciences. My comment or question is related to, again, going back to the definition of success. So being part of the global company, I think success for me would be in global harmonization, the acceptance of these new methods by other countries as well, because it defeats the purpose if even one country requires animal testing, we still have to do it. Interested in panel's comments on that, how to approach this.
Yeah, I can be really quick. I think that if global harmonization results in the exoneration of chemicals, again, like chemicals that are harmful being called safe, then that's really extraordinarily problematic. And so when we think about global harmonization, it's not just a matter of assuring regulatory identical treatment across different regulatory landscapes, but also ensuring that the tools that are being used and the success that I would define as being protective of public health also ultimately translates across that global harmonization. So it's not just necessarily a rush to ensure that different companies have the ability to be able to just use one regulatory frame, but also ensuring that the public is protected across the globe as well.
I just wanted to follow on that. I think that's also a challenge, right? Because you have to get the science right, you have to get the communication right, and then you have to look at the applications maybe in different decision contexts, because the global decision contexts in different areas are not necessarily the same. So it really makes it very challenging. But I think if we focus on problem formulation, again, like I talked about problem formulation to start with, in decision context, and are very explicit in that information that we generate and communicate, then it allows for that analogy to be brought forward and say, does it fit within this different decision context? So I don't think there's a magic bullet for global harmonization that's going to solve that problem, but I think we can work toward that if we're very explicit in the approaches that we take. I also want to just comment one other thing, of course, is that everything is harmful. So the question here is, how do we apply this knowledge to figure out what are those zones of safe exposure? And the evidence the tools that we have are being advanced not just in the biology space, right, but also in the exposure space and dosimetry space. So we have to link all of those together. So it's a collective journey, right, in using these new tools. But there's an opportunity to really bring the biology right at the middle of that and then bring forward those different technologies and apply that in these decision contexts.
So just to add to the exposure piece, so I think that we're still developing our exposure science, especially the high throughput and emerging technologies in that way. And so I would really be cautious to say that we don't want our weakest link to make our chain. And so how do we use exposure tools right now in the ways that are useful, that can inform decision making, but not make the entire decision based upon or reliant upon the field that's the least developed out of all of these tools. And so while everything can be harmful and certain doses can be, more troubling than others, I think that we really need to be able to, again, identify the problem. And if that problem is one in which we can answer with hazard alone or some combination or use of exposure in a way that's different than, say, looking at a dose response or, using really sophisticated models in order to identify internal dosimetry, then we should be able to do that as well.
Maybe a quick comment about everything is harmful. You can imagine circumstances where you can create that, but I do think that small concentrations of lead are much worse for us than small concentrations of water, even though at some point they are harmful. So I think we ought to be a little cautious about saying everything is harmful.
Biology tells us that. That's where, based on the biology and understanding of dosimetry and exposure, can tell us that. It's not inherent necessarily, right? So it's both the potency, the exposure, and understanding of the interactions in the biology systems that produce that degree of concern.
I only want to add that if we have these new tools and they shift our thinking about a number of things about biological activity and function and processes, and if our exposure tools evolve, is it going to make sense to shoehorn those into a risk assessment framework that's based on something from decades ago? And how much do we fundamentally need to revisit the risk assessment framework to accommodate these new tools?
Thank you. I'm Maurice Whelan from the European Commission. Very interesting discussions. Just to go back to Rory Connolly's question on communication, I think it's been shown in recent times that the worst thing a scientist can do is keep trying to explain their science. That it's been well recognized now that people respond much more positively to simply explaining what you're doing and why you're doing it, as opposed to the details of how you're doing it. And that's been a far more, as I say, a constructive way of engaging with different stakeholders who wouldn't have the scientific background. So this science literacy deficit model, let's say, our information deficit model, has been shown not to be appropriate. So I wanted to also just comment on the issue that was brought up by the colleague from Dow, I think it was. It is a very important and challenging issue to find the balance between flexibility and prescriptiveness. I mean, in a utopia where everybody's a scientist and we have unlimited resources, we can think about all of these fit-for-purpose, heavy on the science assessment approaches, chemical by chemical and so on. But the reality is we live in a world where, we have limited resources, we have limited competences, and so we need efficiency in our risk assessment and risk management frameworks. And also we need some level of, let's call it prescriptiveness or certainty in terms of what regulators are expecting to be provided with in terms of information requirements, and what companies can be expected to, anticipate they'll have to give, particularly when the burden of proof is put onto companies. So, we have to think carefully about how we can embrace the idea of standardization and harmonization, particularly with toxicological testing, for example, so that simply the machinery can work. Otherwise, we're going to be spending far too long, assessing individual chemicals and not really dealing efficiently with the many thousands of chemicals that need to be assessed and managed.
Any response from the panel?
Well, yeah, so I think that's probably one of the most promising applications of these new technologies come in, both the exposure science side, predicting exposure, and also in the bioactivity side is inefficiency of maybe doing priority setting. So we talked about 80,000 chemicals in commerce. Well, it's 80,000 on the inventory. The inventory is going to be reset as part of the new TSCA, probably somewhere 15 or 20,000 actually in commerce. That's what Canada has. I think that's probably representative of what we're going to see here. And then how do you do an efficient priority setting of those chemicals based on concerns from potential toxic effects to humans or impacts to the environment? the only way you can do that efficiently is through some of these prediction models and some of these new technologies, right? We can't do priority setting, 10 at a time, 20 at a time. So I think we're going to see, that's maybe call it the grand experiment here in the U.S. under the new TSCA. How can we do priority setting in a way that harnesses the power of these new technologies and allows us then to really focus our efforts on those chemicals that really deserve the focus and put some of those others aside as no further action at this time.
Great. I think I'm getting cut off, yeah? Andre, okay, Andre is like throwing down the gavel. It's over time. So thanks to our panel for doing such a great job this afternoon, and to all of you for all the wonderful questions. I found it very interesting and informative. I hope you guys